Welcome to this video on navigating AI risk assessment frameworks. As AI adoption accelerates, understanding and managing its inherent risks is essential. We begin by addressing the critical need for robust AI governance in today's rapidly evolving technological landscape. AI systems are becoming deeply integrated into business operations. This widespread adoption, while transformative, introduces complex and novel risks that must be proactively managed. Risk management in AI takes a similar process to other systems. It's a case of aligning the risk with the organization's risk appetite. First, we can look at what risks there are to AI systems. Development and operations risks stem from how AI is built and maintained. This includes ensuring compliance with ethical standards and ensuring an appropriate level of competencies of both developers and end users. Development risks include ensuring ethical coding practices, managing the environmental footprint of large models, and addressing internal skill gaps within teams. Operational risks involve managing dependencies on external systems and ensuring rigorous process control for reliable AI deployment. Also consider the risk of unbound consumption and the environmental and financial costs. Another important area to consider are the risks associated with data integrity. The performance of any AI system is fundamentally tied to the quality and sourcing of its training data. Key risks here include modeling inaccuracies arising from poor data and fundamental data quality issues such as incompleteness or errors. We must also mitigate data supply chain vulnerabilities, ensuring the integrity and compliance of all third-party data inputs. We need to consider malicious attacks against the AI systems. This is particularly important with the LLM, large language models. Risks include prompt injection, sensitive information disclosure, and data model poisoning. Also consider that threats can come from the supply chain, where the models are tampered with through third-party libraries. I'll be covering AI attacks in more detail later in the video. Pillar 4, Trust and Compliance, is about managing algorithmic bias, ensuring model transparency, guaranteeing safety, and adhering to critical privacy regulations like GDPR. To understand the trust gap in AI, we have to look at 6 critical risks. First, these models are often opaque, black boxes, where the decision-making process is hidden. This lack of transparency can conceal training data that is biased, which inevitably leads to automated discrimination against specific groups. But the risks go beyond just unfairness. Artificial intelligence can be weaponized to generate misinformation at scale, leading to the sophisticated manipulation of public opinion. If we don't address these issues, we risk building systems that are, at their core, unethical. To achieve true AI compliance, we must build upon 3 distinct aspects. First, we must ensure privacy. This focuses on the data, protecting personal information, respecting user consent, and adhering to regulations like GDPR or CCPA. Next is security. This protects the model itself. It's about hardening the system against the malicious attacks, preventing unauthorized access or tampering. Finally, there is safety. While security protects the system from external threats, safety ensures the system doesn't become a threat to others. It guarantees the AI operates reliably, predictably, and without causing physical or decision-making harm to the real world. As promised, we can take a deeper look at some of the AI attacks in more detail, specifically those that fall into the category of AI manipulation. It is crucial to note why these specific definitions matter. If you are preparing for your AAISM, Advanced in AI Security Management certification, these are not just vocabulary words, they are core domains of study. The exam requires you to clearly distinguish between threats that happen during training, like poisoning, versus those that happen during inference, like evasion. Mastering these distinctions is key to passing the certification and, more importantly, to building robust AI defense strategies in the real world. First, we have prompt injection. Think of this as, quote, social engineering for an AI. Here, the attacker isn't hacking code. They are crafting a carefully worded message that tricks the model into ignoring its safety guidelines and doing something it shouldn't, like leaking internal data or generating harmful content. Next is model inversion. This is a privacy attack. The attacker analyzes the model's outputs, its answers, to work backward and reconstruct the sensitive data it was trained on. Importantly, this does not break how the model works. Instead, it exposes the private secrets hidden inside it. Then we have evasion attacks. To understand this, we need to clarify what we mean by inference. In the world of AI, inference is simply showtime. It is the phase where the model is finished learning and is actually using its knowledge to make decisions on live data. In an evasion attack, the adversary alters the input during this showtime phase to deceive the model. For example, putting a sticker on a stop sign so an autonomous car thinks it's a speed limit sign. The model isn't broken, but it is being fooled in real time. Finally, there is data poisoning. Unlike evasion, which happens during showtime, poisoning happens during rehearsal, the training phase. The attacker secretly injects malicious or wrong information into the dataset before the model is even built. This creates a quotes sleeper agent effect, where the model learns the wrong lessons from the very beginning. I initially found these difficult to remember, so here's a little hint I generated using AI. Consider data poisoning as the chef adding the poison to the training data. Evasion is the criminal with his fake glasses and mustache, which is the modified input to fool the camera. The detective uses model inversion to figure out the secrets from the training data. The hypnotist successfully performs a prompt injection by tricking the AI into ignoring its own rules. I'd also like to share a personal example of AI evasion, although in this case it is legitimate use of the AI toolset. This video is created with Google Vids. One option I sometimes use is an AI input, which helps create some of the initial slides. When I tried to generate the slides for this video, I received the error shown here. Although it doesn't say as much, this is what you get when you encounter the AI guardrails. I asked Google Gemini why it was failing. It suggested that it was likely hitting these guardrails, and helpfully rewrote my prompt in a way that it was acceptable. Although this is not an AI attack as such, it shows how a change in words or emphasis can make a difference. Note in the topic of AI trust, I can assure you that whilst I do use AI in the creation of these videos, I also create much of the content myself, and it's all carefully reviewed with appropriate human oversight. Now we've looked at what the risks are, we can look at how we identify and manage those risks. Effective AI risk management is not a one-time task. It's a continuous cyclic process known as the Risk Management Lifecycle, or RML. This shows the cycle. Step 1 is to identify the threats. Step 2 is to analyze, evaluate, and assess the threats. Step 3 is to respond, and then Step 4 to monitor and record the findings. It then continues back to Step 1, learning from the previous steps. Now, let's explore the two primary frameworks guiding AI risk management today: the NIST AI Risk Management Framework and the European Union's Artificial Intelligence Act. The NIST AI Risk Management Framework provides a flexible, voluntary guide to managing AI risks and ensuring trustworthy systems across various sectors. The European Union's AI Act is the world's first comprehensive legal framework for AI, categorizing systems by risk level and imposing strict compliance requirements. Adopting these frameworks proactively is vital for building trustworthy AI and future-proofing your organization against evolving regulations and threats. Thanks for watching. I hope you found this useful. If so, please give the video a thumbs up. Let me know in the comments if there is something you'd like to see in future videos. Don't forget to subscribe if you haven't already, or see my website penguinfortress.com, which has lots more content on cybersecurity, including AI systems. I look forward to seeing you on a future video.